Okay, in this video I'm going to talk about the information that is given being side-side angle. And if I have that, there are some different things that can happen, and that is why we call this the ambiguous case. So if you look at these pictures, it kind of just goes to show that there are different things that can happen with this. If I just give you the length of this side, which you see with both triangles is the same thing, and then the length of another side, and again all I'm giving you is the length, I'm not telling you which direction that goes, and then I give you an angle. And if you look at these two angles, they're the same, and those side lengths are the same. And so with that information, I can have a couple of different triangles that have that information of side-side angle. So we'll look at a few examples here where some different things can happen given that information. So this first one says that I'm going to have a one solution case. So it is possible that given the information that I have, I'm only going to be able to find one triangle that works with that information. And so it says I have a triangle ABC. With this case, by the way, the triangle would never be drawn because sometimes I'll have a couple different triangles that could give me that, like I do up here, or some different things can happen. So those be written out like this. If you want to draw a triangle right off the bat, that's fine. Just know that such a triangle may not exist. So I'm going to avoid drawing the triangle, but what I'm going to do is I've got my information for A, and I have a piece for B, the side length of B, and so I'm going to go ahead and set up the law of sines that says the sine of 45 degrees is to side length A, which is 7√2, and that's going to equal the sine of angle B, which I am going to be trying to find, and side length B. So now if I just try to solve this using my cross products, we're going to end up with 7√2 times the sine of B equals 7 times the sine of 45 degrees. If I divide by this 7√2, I end up with the sine of B is equal to, I'm going to go ahead and cancel those. It's going to give me the sine of 45 degrees divided by the square root of 2. I'm going to go ahead and evaluate this without the use of a calculator for right now. You don't have to worry about this. You can use a calculator if you want to, but this is a nice angle, sine of 45. I should know that the sine of 45 is the square root of 2 over 2. And then if I have that divided by the square root of 2, these are essentially going to cancel, giving me a 1 on top. So I'm going to have the sine of B should be 1/2. Sine of B should be 1/2. Now, that means, again, I'm trying to look for this angle, which means at this point in time, that angle B is going to be the inverse sine of 1/2. So what we're asking ourselves here is, what angle has a sine of 1/2? And if you think about this, the angle that I'm going to be looking for, and this is going to be very important when we do this, along with what we do in our next video, our angle should always be between 0 and 180, right? That should make sense because when I have a triangle, every single one of those angles should be somewhere between 0 and 180 degrees. So you may just want to always keep that in mind. So if I'm trying to find what angle has a sine of 1/2, we've actually got a couple, right? Angle B could be 30 degrees. If I look at my unit circle, or if I plug this into a calculator, inverse sine of 1/2 is going to tell me 30. But there's another angle between 0 and 180 that has a sine of 1/2, and that is 150 degrees. Right? So those two angles both have a sine of 1/2. So this is why I'm going to have some different options that come up. So you should ask yourself, well, if angle B is 30 degrees, then what would angle C be? Well, angle C would simply be 180 degrees minus what I get for angle B, minus what I had for angle A, which was 45, which is going to give me an angle of 105 degrees. So angle C equals 105 degrees. I also want to check to see what if angle B is 150 degrees. Well, if angle B is 150 degrees, then angle C, the third angle I don't know, would be 180 minus 150 minus angle A, which is 45, which would give me negative 15 degrees, and that doesn't make sense, right? So this is why this is a one solution case, because one of these two angles that I got for B doesn't work. B can't be 150 degrees, because if it were 150 degrees, then my angle C would be negative 15, and that doesn't make sense. So therefore, I only have one such triangle that has this information, and now I've got basically everything that I need. I know that angle A is 45. I know that angle B has to be 30. And I know that angle C then would have to be 105. I know side length A is 7 root 2. I know side length B is 7, so now the only thing I need to find is side length C. And so I'll set up a law of sines to do that, and I need to use angle C. So sine of 105 is to C as, and you can use any piece of information there that you want to use. If you use the information for B, the sine of 30 degrees is to 7, which means C is, the side length C is simply going to be 7 times the sine of 105 degrees divided by the sine of 30 degrees. And that gives us an answer of 13.5. Okay, so there is a situation where I have one case, only one such triangle that will have that information. So the next one says, what if there are a couple different solutions? So I've got this information here. I'm going to start off trying to solve this exactly like I did the one before this. So that part doesn't change. I have the sine of my angle A, 43.1 degrees, is to side length A, 186.2. And I'm going to say that equals the sine of angle B to 248.6. So now if I do my cross products, and I'm going to kind of skip a step here. I'm going to see if you guys follow along on this, and if not, let me know in class. But if I'm trying to find an angle, that means I'm automatically going to be saying that that angle is equal to the inverse sine of something, and it's going to be this other cross product, which is 248.6 times the sine of 43.1 degrees, divided by this 186.2. Now I hope that we can get there, so it's only one step, and it's going to be a lot quicker for us, especially if I have to try to find a couple of different triangles that have that information. So that's going to give me that my angle B is going to be, maybe if I can get this to work, my angle B is going to be, if I do the inverse sine of that, my calculator tells me 65.8 degrees. Now, again, you might say, well, in the calculator, it's only going to tell me one measure there. It's only going to tell me 65.8, and that's true, it will. But I always need to remember that there are two angles where their sine, between 180 degrees, where their sine is going to be that same value. So what I need to do is to find, and I'm going to always call this my first one. Angle B1 is going to be that. Angle B2, my other possibility for angle B, is simply going to be what I get when I take this first angle and subtract from 180. And if that doesn't make sense, let me just go back a page. Those two angles that had a sine of 1/2 were 30 and 150. That's simply going to be 180 minus the first angle that I got, right? So that's always going to be the case. To find that second possibility for angle B, just subtract it from 180. So 180 minus 65.8 is going to give me an angle of 114.2 degrees. So what I have here is, I'm going to go ahead and write this down. Angle A is 43.1 degrees. I know that side length A is 186.2. I know that side length B is 248.6. Now, before I go writing down what angle B is, or that it's both, I do need to check to make sure that it can be both. So again, I'm going to do what I did with the last problem in saying that if angle B is 65.8 8, then angle C, and notice I'm going to use the same subscript with that one. Angle C would be 180 minus angle B1, which is 65.8, minus angle A, which is 43.1, which would give me an angle measure of 71.1 degrees. And also, if angle B is 114.2, then angle C would be 180 minus 114.2 minus 43.1, and that would give me an angle measure of 22.7 degrees. And since both of these are positive angles between 0 and 180, that means that both of these were options for angle B. So when I write that up here, I'm going to have to list everything. I'm going to say angle B1 could be 65.8 degrees, or angle B could be 114.2 degrees. And then I'm also going to say, well, that means that angle C could be 71.1 degrees, or it could be 22.7 degrees. And so then my other stuff that I have that's unknown here is, what is side length C? Well, I'm going to have 2 of those. Okay, so the stuff that is given, you only have one option for. Angle A only has that one option. Side length A, side length B only have those one options. But if I had 2 different options that worked for angle B when I solved that, that means I have 2 different options for angle C, which means I'm going to have 2 different options for side length C. And the way I'm going to find that is by simply doing the law of sines with each one of these angles as my C value. So the first one I'll use is 71.1. Sine of 71.1 is to side length C1, because I'm calling this angle C1. And I'm just going to use the information from either, I'm going to use it from A, because I'm not going to have to change this. You would need to be careful if you used angle B, and making sure that you use the information for B1 for this one and for B2 for this one. So if you just use that stuff for A, you won't have to worry about that. So 43.1, and over here 186.2, which means C1 is going to be 257.8. And then all you would really need to do to find C2, the only thing I'm going to do is change this out for my other option for angle C, right? So I could do the sine of 22.7 is to C2, and all this other stuff would stay the same. This would be sine of 43.1, this would be 186.2, and I could solve for C2 that way, which would give me an answer of 105.2. Okay, so I've got some options there. So again, I've got 2 different triangles. They both have this information in red. If angle B is this, then angle C is this, and side length C is this. If angle B is this, then angle C is this, and side length C is this. So just make sure that that's all organized in one spot. If you want to put the stuff with each one of those possibilities and write it out kind of twice, you can do that. But as long as you put the subscripts there, I'm okay with that. So based on the information that was given there, we've got a couple of different triangles that would work. Okay, so then it also says we could possibly have this given information of side-side angle where there is no such triangle that gives us that. And the work here is going to be pretty quick. Again, I'm going to try to do this the same way I've been doing all the other ones. The sine of angle A is to the side length A as the sine of angle B is to side length B 122. And I do my cross products, and again I'm going to end up with angle B equals the inverse sine of something, and that something is going to be 122 sine of 42 degrees over 70. And if you type this into a calculator, it will tell you that angle B is undefined. Now, that's enough to tell you that this doesn't exist, but I'm going to ask you, why does it say that? Why would it tell me that angle B is undefined? To explain that, I just want to look at the value of just this stuff, not what the inverse sine of that is, but just that stuff. If I do 122 times the sine of 42 degrees and I divide by 70, I get 1.1662. And so what I'm really looking for is what angle, right? I'm going to do the sine of B. What angle B has a sine value of 1.1662? What angle has a sine of that? Now, if you think about how sine works, and I'll just draw the graph of sine real quick, and you can think about the unit circle as well. If I think about how the sine function works, it just keeps on doing the same thing over and over and again both ways, right? It goes this way forever like that, and it goes this way forever like that. And my question is, where is that bounded on the top and the bottom? Where is the very top of the wave get to, and where does the very bottom get to? And that should be 1 and -1, right? The values for sine, no matter what my angle is, when I take the sine of that angle, I'm always supposed to get something between -1 and 1. And this is not in between -1 and 1. That's why angle B is undefined, and because of that, there is no such triangle. No such triangle where I can have an angle A be that, the side length be that, and the side length of B be 122. That just doesn't work. So you could just stop there. You could say no such triangle. I guess simply just not solving for everything else shows me that there's not a triangle there as well. So this side-side angle is the difficult case, and something that we'll need to work at and make sure that we're always checking, is there 1, 2, or no triangles that have that information.